second part of fractions. And in this class, we will learn how to compare fractions, how to determine the least common denominators, and what is mixed number. We'll start with comparing fractions. Comparing fractions means how to determine which fraction is greater than the other one. Because for numbers, for real numbers or integer numbers, we can easily compare which number is greater or smaller. But for fractions, because fractions contains two components, the numerator and denominator, so sometimes it's not very straightforward to compare which number is greater or smaller. So, for example, if I have a number 3 over 5 and another one 4 over 5, and I want to know which one is greater, this is a very easy example. We can even quickly find it from the number axis. Because they have the same denominator, that means I can split the 0, 1 segment into 5 even parts. Each part or each subsegment has a length of 1 over 5. So 0 over 5, 1 over 5, 2 over 5, 3 over 5, 4 over 5, and 5 over 5 is 1. So this can be easily tell from the number line that 4 over 5 is on the right hand side of 3 over 5. So 4 over 5 is greater. Or in another way, because they have the same base, the same denominator, so that means if 3 is less than 4, we can tell that 3 divided by 5 should also less than 4 divided by 5. Right? Because if 3 is less than 4, and if both numbers are divided by the same positive number, then 3 over 5 should also smaller than 4 over 5. So this is an easy example because they have the same denominator, so you can easily draw them from the number line or just compare them in a relatively direct way. So if we see another example, what if I want to compare 3 over 5 with 7 over 10? Now they have different base, they have different denominator. It's not that straightforward anymore, but you can probably easy to tell the relationship between the two denominators. One's 5, the other one's 10. It's 2 times of the first fraction. So that means I can convert one of the fraction to have the equal denominator with the other one. Then we can start comparison. So we need to do one more step of conversion first. 3 over 5 can be written as, if I'm multiplying 2 on both sides of the fraction, it's equivalent to multiply by 1 to the entire fraction, and anytime times by 1 is still the number itself. So this equals 6 over 10. Now I have a fraction that has base 10, so that I can compare with the other fraction which also has a base 10. So then, because I know 6 is less than 7, so then 6 over 10 is less than 7 over 10, and that means 3 over 5 is less than 7 over 10. Right. Okay, then let's see a further example with a little bit more complicated situation. Then I still have two fractions I want to compare. They obviously has different denominators, and they also don't have a clear or direct relationship between the two denominators, because 7 and 11, none of them are a divisor factor of the other one or multiple of the other one. And they are actually prime numbers or relatively prime between the two numbers. So how can I use the same way to compare these two fractions? Then based on the example we had before, intuitively we still want them to first convert it to a fraction that has the same denominator. Then if they have the same denominator, then I can just simply compare the numerator to tell which one's bigger and which one's smaller. And how do I get the same denominator? We can still hint by the previous example, even though they're not having a simple relationship that one number is the divisor or multiple of the other one, but you can still create a common denominator. So then now you probably remember that what we just learned in the previous lesson, to find a common multiple. Right, so in this case, between the number 7 and 11, the common multiple is 77, or at least the number 77 is a common multiple. So then 5 over 7 is 5 times 11 over 7 times 11, so it's 55 over 77. Same, 8 over 11, 8 times 7 over 11 times 7, because I want to make my denominator equal to 77. So for this one, I need to multiply 7 on both sides. So it's 56 over 77. Because 55, now I have both numbers with the denominator of 77. I have 55 less than 56, so that I can tell that 5 over 7 is less than 8 over 11. Now you probably see a pattern or a common way or a general method that seems can be used to solve this type of question. So that means we always want to have the same denominator for the comparison, and the way how to get the same denominator is to find the common multiple between the two denominators or between the multiple denominators. And then further, obviously you don't want to get your numbers overcomplicated. So we're not only just find the common multiple, but we're finding the least common multiple or the least common denominator. Right, so one more example. If we want to compare minus 17 over 14 and minus 41 over 35. So first of all, they have different denominators. I need to find the common denominator first. And then to find the common denominator, it's equivalent to find the least common multiple between 14 and 35. If you still remember, find the LCM of two numbers, I need to write them out as the prime factorization. So 14 is 2 times 7. So it's just 2 and 7. 35 is 5 times 7. So it's 5 and 7. So I have a common, well, I have a factor of 2, a factor of 5, and a factor of 7. Both has the maximum power of 1. So it's 70. That's the LCM. That's the least common denominator. So then the first number can be converted to 5 times 14 is 70. So I need to multiply a 5 on both numerator and denominator so that this can make your denominator equal to 70 later. So this will be 5 over 70. Next one is 41 over 35. This time I need to multiply 2 on both sides to make in order to make this number to be 70. So it's 41 by 2, 35 by 2, 82 over 70. Now be careful that they are negative numbers. So for negative numbers, I have so 85 is greater than 82. So minus 85 is smaller than minus 82. So that minus 85 over 70 is still less than minus 82 over 70. And so that minus 17 over 14 is less than the other number, 41, minus 41 over 35. Right, so this is how we compare two fractions, and this universal methodology can be used to compare any form of the fractions. Right, so then once we're able to compare fractions, that means we're able to find the common denominators. And by finding the common denominator, it means that we will also be able to simplify fractions or simplify the addition, subtraction, or multiplication and divisions between fractions. So this also gives us a technique to simplify a expression that contains fractions. And before we do the simplification, there's another useful formula that we probably already saw that in the previous lesson, but let's just take a look again. So that's division by a number distributes over addition and subtraction. So that simply tells that if I have a plus b over c, it can be redistributed as a over c plus b over c. Or if I have a minus b over c, it can be redistributed as a over c minus b over c. So we saw that actually in our last class. So here it's just write it down again, that because these rules would be very helpful when you simply do simplification to the fractions. Right, so for example, if I have 17 over 18 minus 5 over 18, this is actually the same way that how we compare the fractions by having the common denominator. So if you already have a common denominator, you would also be able to do the simplifications. The common denominator here is 18, so which means I can just write 18 as the denominator of the number that after simplification, and then the numerator would be just 17 minus 5. And so that I can simplifying a single subtraction from the numerator first, so that will give you 12 over 18, and then we had that before as well, that we can further simplify this fraction by cancel out or by dividing the common factor from numerator and denominator. So in this case, I can see that 6 is a common factor. So 12 divided by 6, 2, this divided by 6 is 3. And 2 and 3 has no further common factor, so that the simplified form of this expression is 2 over 3. Okay, so then let's see more examples to further practice. what is 15 over 25 minus 900 over 1400? So it's a subtraction between fractions. So we can do the subtraction by using this rule, and then before using this rule, we would need to find the common denominator or the least common denominator first, right? That's the standard way. However, of course, before you apply the standard way, you always want to simplify the fractions first, because that will save you a lot of calculation works, and this will make your question starts with a relatively easier form. And in this one, obviously, I can tell that there's a factor of 100 can be canceled out over here, and the first fraction has a common factor, at least has one common factor of 3, because those numbers are divisible by 3. So then this divisible by 3, so it's 5 over 8. This one divided by 100, I have 9 over 14 left. Now up to here, I think each fraction is in the simplest form already. And in fact, as long as those numbers are simple enough, you don't have to get the simplest form, because you will do the subtraction anyway, and you will do the final simplification in the last step anyway. So as long as you think those numbers are simple enough, you can start do the subtraction. And in other words, you can start by looking for the common denominator. So now, because I want to combine these two numbers, that means I need to find the common denominator, or the least common denominator. So the LCM of the two denominator, 8 and 14, would be 8 is 2 cubed, 14 is 2 times 7, so 2 times 7. So the factors with, or the common factors with highest power is 2 cubed and 7. So it's 56. So now I have the common denominator. So convert the first number, I need to multiply a 7 both sides. Converting the second number, I need to multiply a 4. So this gives you 35 over 56 minus 36 over 56. And then this will be 35 minus 36, so that's minus 1 over 56. And there is no further common factors, or there's no further way to simplify this, so that's the simplest outcome of this example. So the next one, we can, of course, not only just do the addition or subtraction between two fractions, we can doing the same thing amount more than two fractions, or many fractions, as many as you want. So next example, let's do this with between 3 fractions, and all 3 of them having different denominators. So there are actually many different ways. You can choose to do the addition or subtraction among the 2 of the fractions first, get one result, and then do the addition subtraction of the other 2's and then put them together. So this is one way. Or the other way, if the numbers are not so complicated, or there's not too many terms, you can of course also do this 3 or more than 3 fractions all together. So by doing them all together, that means I need to looking for the common denominator for all 3 fractions. So it's really just the LCM of the 3 denominators. That would be 5 is just 5, 4 is 2 square, 6 is 2 times 3. So I have 2 square, I have a 3, I have a 5. So it's 60. So 60 is the least common denominator. among the three denominators. So then to convert the first one, 5 need to times 12 to get 60. So 6 by 12. And then 4 need what? Need a 15 to convert this to 60. And then this needs a 10. So it's 7 by 10, 60. And then this is 72 minus 135 plus 70 over 60. So looks like it's easier to combine these two numbers first. I have 142 minus 135, and that's just 7 over 60. And there's no further common factors between the number 7 and number 60, so that's the simplest form already. So that's my the results of this question. Okay, the next example, we can also use the same method to determine or to locate a fraction or locate the subtraction of or addition of several fractions. Basically, when we say locate, that means to looking for the nearest integer between certain fractions. So what is the integer that closest to 87 over 88 plus 24 over 23? This time let's do this in a reversed way or opposite way, because of course you can still do the fraction addition by finding the common denominator and do the addition to the number, and then eventually round that fraction number to the nearest integer. But this example looks a bit special because if you see the numerator and denominator, you find that they are already very close. They're just has a tiny bit difference between both numbers. So that means I can rewrite, before taking the addition, I can rewrite my fractions. 87 can be written as 88 minus 1. 24 can be written as 23 plus 1. And the reason I'm writing this way is then later on when I apply these redistribute over addition subtraction, one of the components will be simplified to a rounded integer. For example, this one equals to 88 over 88 minus 1 over 88. So it's 1 minus 1 over 88, right? And then this is 23 over 23 is 1, then plus 1 over 23. So it's 2, right? 1 plus 1. 2 minus 1 over 88 plus 1 over 23. Now, the reason I'm doing it this way, because I don't even need to further calculate the actual value of 1 over 88 or 1 over 23, because I know that 1 over 88 and 1 over 23 are both very small number, much smaller than 1. So then the closest integer will be 2, right? Because 2, for number 2, even you are subtracting a very small number and adding another very small number, it's not the number 2 anymore, but it's still the closest integer that is still 2. Okay, next example. Let's have a relatively more complicated expression. In this example, I have 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, 4 times 5, 5 times 6. So I have a sequence with a certain pattern. and they are all fractions, and I want to find the summation of this long expression. So yeah, again, like these are just fractions. You can use the standard way to find the sum of all these fractions. But because there is a pattern, we always want to see if we can summarize the pattern first, and to see if we can take any advantage from the known patterns. For example, the first number, 1 over 1 times 2. If this is not clear to you, at least I have 2 is 1 greater than 1, and the numerator is equal to 1. So for example, if I have, I can try both actually. If I try 1 over 1 plus 1 over 2, I will have the common denominator is 2, so it's 2 plus 1 over 2. That's 3 plus over 2. It's not the same, but then how about 1 over 1 minus 1 over 2? I will have the common denominator of 2, and then, as I just said, I know I can observe that 2 minus 1, or 3 minus 2, or 4 minus 3, so the difference between each pair of numbers are always 1. So yes, it is. So 1 over 1 minus 1 over 2 is 1 over 2. So that means, and 1 over 2 is 1 over 1 times 2. So that means if I'm trying to break down any number n and multiplying with the other integer that 1 less than n, I always have this relation. Because if I'm taking the common denominator of these two fractions, on the numerator I will get a n minus 1 here, and here is a n. Sorry, it's a minus n. So n minus n will cancel out, and this will be minus 1 over 1 n times n minus 1. Or in other words, it's the minus, or the n over 1 over n minus 1 minus 1 over n. Right, so here I'm just trying to prove that how to break this down in the separate form of two single fractions, adding or subtracting together. Okay, so by knowing this, or by observing the pattern from the first combination, this gives us a way to, well, it seems like it's not simplifying the expression, but when you're breaking this down, you will find that this will help you to canceling out or eliminating some of the terms or many of the terms before you do the, right, and you keep writing to the last term, which is 1 over 5 minus 1 over 6. And now you can see that each pair of the number doesn't seem to have any further simplifications, but if you're comparing the two neighboring pairs, you will find that the last term of the first pair can be cancelled out with the first term of the second pair, and one by one. Right, so minus 1 over 5 plus 1 over 5. And that eventually cancels out all the middle terms, and only having the first and the last term left. And all the other terms are plus or minus the same value that can be, right, the sum will be 0. It can be zeroed out or canceled out. And then eventually only have 1 minus 1 over 6, which is much easier to calculate. So eventually it's 5 over 6. So these are the examples of calculating or simplifying expressions that contains fractions. So lastly, let's see one more concept, which is mixed number. So mixed numbers, you probably also saw that in some of the previous courses, or saw that in some other places, that sometimes we can also write fractions as a combination of integer part and fraction part. So for example, if I have a number 37/4, I know that this is something that much greater than 4, so 37 divided by 4 will definitely give you a answer that greater than 1, so which means I can rewrite this as 36 plus 1, because 36 is a multiple of 4. Then I know that this is 36/4 plus 1/4, where the second component is something less than 1. The first component is the numerator is a multiple of the denominator, so that is simplified to be 9 plus 1/4. So that you have integer part and fraction part. And then this, sometimes people in short will write this as 9 and 1/4. So here I don't have a dot. If you have a dot in between or multiplying sign in between, that means the multiplication. But if you have nothing in between, that means the addition or the plus. So the mixed number is the integer part plus a fractional part, where integer part is always integer, but the fractional part means that you're trying to leave the fractional part as a number that's smaller than 1. It will also greater than 0, because if it is equal to 0, that means there's no fraction part, and the whole number is a multiple or a rounded number that you don't even need a fraction for. So here the fractional form means you will have some remainder left out, and we're trying to write the remainder together with the denominator, so that this would always be a fraction that less than 1. So why we want to write in this form? Because this sometimes will help us to give a sense of how large or how big the number is. Because if I'm telling you that I have a number 37/4, or I have I'm 37/4 hours from finishing a job, then you don't have a sense of how long exactly this time is. It's definitely not 37. It's also not 4. How long it is, I have no sense. But if I tell you that I have 9.25 hours from finish this job, I may still not having the exact amount, but at least I know it's 9 hours plus something less than 1 hour. So that gives you a direct sense that I'm 9 hours, between 9 and 10 hours from finishing this job. Okay, so this, in other words, will easily give you a range of the two neighboring integers around this number. And then by having this mixed number form, we can still perform the same operations like addition, subtraction, or comparison between the two fractions under mixed number form. Right? For example, if now I want to calculate 6 and 4/7 minus 8 and 2/7, I have two ways actually. Option 1, approach 1, I can convert both into back into fractions, and then I do the fraction subtraction that I just learned. Let's try this way first. So this means 6 times 7 plus 4 over 7. Right? If you don't get this equivalent to 6 plus 4 over 7, and then this further equals to 6 times 7 over 7 by looking for the common denominator. And then this is 6 times 7 plus 4 over 7. Minus similarly 8 times 7 plus 2 over 7. This is 42 plus 4, 46 over 7. 56 plus 2, 58 over 7. And 46 minus 58, it's minus 12 over 7. And then if I want to further convert this back to mixed number, 12 divided by 7 is 1 with remainder of 5. So it's 7 times 1 plus remainder of 5, right? 12 is 7 plus 5. And this is minus 1 and 5 over 7, right? This is 1, this is 5 over 7 left. So this is one of the approach. The other approach we can use now is we can also do, instead of converting them all back to one fraction, we can also do the subtraction or addition or any other operations separately for the integer part and separate for the fractional part. Like of course for addition and subtraction, it will be just simply operating the integers together and operating the fractions together. But be careful for multiplication and division because you still want to follow all those rules of the redistributions or order of the calculations. So here I have integer parts, that is 6 over minus 8. And then the fractional part is 4 over 7 minus 2 over 7. The first part gives me minus 2. The second part gives me 2 over 7. It's a positive 2 over 7. And I still need to combine them together by looking for the common denominator. Right, so then this again is minus 12 over 7. And from minus 12 over 7, you can simply find this in this form. And there's another form to write the mixed number form. That is, I know I will need to combine them together once again, but they have different sign, right? So they have different sign means I need to split this minus 2 with at least one rounded number, one integer, right? This 1 that to combine with the leftover part of the fraction, and then this is minus 1, right? This is minus 7 over 7, and minus 7 plus 2 is minus 5, so it's 5 over 7. Now, because they both have minus sign, so then this can be written as minus 1 and 5 over 7. So we get the same results from all 2 or 3 different approaches. Okay, let's then see an example of multiplications between mixed numbers. So if I have 3 times 4 and 3 over 5. So the first approach, I can still convert this into one single fraction first. That's 4 times 5 is 20, 20 plus 3 is 23. And then I do the multiplications right away. I have 69 over 5. And then I can further simplifying or converting this back to the mixed number. Uh, Here I will use a quicker way. 69 divided by 5 is 1, that's a 19. 3 is 15, 19 minus 15 is 4, so the remainder is 4. So 13 and 4 over 5. Okay, and then the other example, if this involves division, have this divided by 2. Again, I can convert the first number to be 3 times 7 is 21, so 21 plus 1 is 22. Here I can use 22 divided by 2 directly, but if you want to use the techniques we just learned for fractions, that's equivalent to times a 1 over 2, and then a factor of 2 will be cancelled out by between these two numbers, you have 11 over 3 left. And then 3 times 3 is 9, so in other, or 11 divided by 3 is 3 with remainder of 2. So 3 and 2 or 3. Okay, so far we have been learned all the techniques between or for fraction numbers or fractions. And maybe let us just write down one more time of all the useful formulas we have been learned. So for example, we learned multiplications between fractions. If I have a over b times c over d, this can be written as a times c over b times d. And then for reciprocals, if I have a over b with the power of minus 1, that is the reciprocal of a over b is simply flipping this over as b over a. And similarly, if I have a over b divided by c over d, this will equivalent to a over b, because divided by this means multiplying its reciprocal. So then this equivalent to a over b times d over c, the reciprocal of this, and then further this is a d over bc based on the multiplication rule. What else we have? We have powers, raising to powers. A over b with nth power can be written as a to the nth power over b to the nth power. And then similarly, the reciprocal of nth power is a over b to minus n. It's reciprocal of nth power, so that's b with nth power over a with the nth power. And finally, what we just learned in this class, the redistribution. So a plus or minus b over c, you have the common denominator of c, that is equivalent to a over c plus or minus b over c. So these are all the useful formulas for operations between fractional numbers.